Hi, my name is Halil. I'm studying electrical engineering at the University of the Witwatersrand. In the short video, I'll give a brief overview of the concepts involved in my final year lab project. My partner is Luxor.
Hello, my name is Luke Sru. I'm a fourth year electrical engineering student at the University of the Witwatersrand. In the next 3 minutes, I'll give a brief overview as to how code was used to automate the measurement process. This video is the open day presentation of our fourth year investigation lab project, electromagnetic compatibility pre-compliance testing.
Before electronic devices can be distributed to the public, the electromagnetic radiation they emit must be measured and compared against the EMC standards for approval. However, this procedure of compliance testing is usually expensive and companies prefer to do in-house pre-compliance testing until they are sure they can pass their compliance tests. For this purpose, in this project, an LPDA antenna and a spectrum analyzer are used to measure radiation of devices for pre-compliance testing purposes. However, the spectrum analyzer gives the voltage that's incident on its ports, whereas the standards are defined in electromagnetic field strengths. To find the electromagnetic field strength, the voltage found is added to the antenna factor of the LPDA. One of the main goals of this project was to find the antenna factor of the LPDA in the frequency range 600 MHz to 2 GHz. The antenna factor is dependent on the LPDA's gain. The two antenna method was used to determine the gain of two identical dipoles from which one of the dipoles were paired up with the LPDA to find the gain of the LPDA.
Python, a high-level programming language, was used to control the Vector Network Analyzer, or VNA, remotely. This device was used to find the gain of the dipole and LPDA antennas. Controlling the VNA from a computer gave myself and Hallelujah the ability to measure the characteristics of up to 14 different dipole antennas quickly and efficiently. The results obtained could be graphed for visual verification and saved to a file for future use. 14 dipoles of different lengths were used to find the gain of the LPDA antenna from 600 to 2000 MHz. These dipoles were shortened to move the valid regions of the antennas throughout the 600 to 2000 MHz range. The valid regions of each antennas were determined automatically by the computer and the corresponding valid results were saved. These valid regions were then graphed so we could compare the results with our expectations before the antenna was further shortened. The first 4 LPDA gain graphs can be seen where the computer determined a valid region for each one with some overlap between them. This was to ensure the entire region is included. All 14 different valid regions were then grouped, with overlapping areas averaged out, to prepare this final graph of the gain of the LPDA antenna throughout the desired frequency range. This result was also saved to a file and later used to calculate the antenna factor. This antenna factor can be used to determine if a device upholds the EMC standards. The final piece of code that uses the value shown in this graph can be manipulated in various ways, changing a variety of things from frequency range to measurement accuracy. This will allow the end user to comprehensively have their needs met.